Hello everyone, welcome to today's class. This is Teacher Simon taking you through IGCSE Core Mathematics paper 0580-13 for May June 2025, and this is part 1. Questions 1 to 13. Question 1, part A, write the number, this one here in words. Now you can see that we are seeing these are 6 zeros, that is a million, and then this is 70. So I can say this is 70 million. 70 million. You can even say millions, no problem. It's a million or millions. Then part B, Roman 1, write down the value of 5 in the number 0.25. Give your answer as a fraction. Now 0.25. This 2 here is in the 10th place. Tenths. Then this one here is in hundreds. Okay, so that means we shall have that 5 then times 100 is 1 over 100, right? Which is going to be equal to, this 5 can go here once, then here 20. So we shall get our answers 1 over 20, and that is that. Then Roman, to find the value of the reciprocal of 0.25. Now 0.25 is the same as 25 out of 100, which is actually the same as what? A quarter, right? So because 25 goes here 4 times, then the reciprocal, I'll take this one up and then the 1 down. That means I will get my answer as 4 over 1, or you can just write 4. Then question 2, part A, write down the mathematical name of an angle between 90 and 180. That is what we call obtuse angle. Angles which are in between 0 and 90, those ones we call them acute. Okay, then 90 to 180, obtuse. Then 180, greater than 180 but less than 360, we call those ones what? Reflex. Okay, then part B, write down the mathematical term that describes 2 polygons that are the same size and shape. Those ones we call them congruent. Congruent shapes. Okay, if, like for example, I can have this square here, and then I have another one here which is big, like this. So maybe this is 3, this is 6, and so that means I've multiplied each and everything, the sides, by a certain scale factor, let's say 2. Now these ones are similar. Okay, they have same angles, same corresponding angles, but the lengths are connected by a scale factor of enlargement. In other words, there is a constant ratio. This 6 divided by this is the same as, this one here divided by this is the same as this one here divided by this. Okay, for similar shapes, they have the corresponding angles are equal, but the corresponding sides are in a constant ratio. But for congruent, I can have a triangle maybe like that. Okay, and then I can have another one here like this. Maybe it has been rotated, something like that. This one corresponds to this. Okay, maybe this one corresponds to this, and also this one corresponds to this. And then the angles are also the corresponding angles are equal, so we call those ones what? Congruent. Okay, question 3, part A, write down root of 169. That one has to be 13. Okay, you need to know these square numbers. So root of 169, 169 is 13 squared. Then Now square root is power half. So using rules of indices, we shall have 2 times that half, then this one will cancel with that, and then you get this 13 here. You see? Then part B, work out the value of 2 power 4. 2 power 4 is the same as 2 times 2 times 2 times 2. This one here is a 4. Then times this one here is a 4. That means you have 4 times 4, which is what? 16. So that is 16. And then part C, work out the value of 10 to the power of negative 2. So 10 power negative 2, using rules of indices, it will be 1 over 10, then power 2. This one, when it goes down, then it becomes what? A positive here. And that one is the same as saying 1 over 10 squared is 10 times 10, which is 100. So I'll have 1 over 100. Or I can even say 0.01. You see? Then part D, work out negative 18 divided by negative 4. Now, a negative divided by a negative, we actually get a positive. Okay? Then, so this one will cancel with that. Then we shall divide this one by 2, and also this one by 2. So this one will give us a 9. Then down here we get a 2. So I can write my answer as 9 over 2, or I can say 4.5, okay? Or I can say for whole number 1 over 2. So whichever you want to write. But you write one answer. Don't write all of them like this in an exam, okay? Then part E, work out 1.6 times 0.02. Now what you can do for such numbers, you write fractions, okay? 1.6 is the same as 16 out of 10. Then times 0.02 is the same as 2 out of 100, okay? So 16 times 2, you actually get 32. Then 100 times 10, you get 1000. So we shall move 1, 2, 3. So the decimal comes there, then here we shall put a 0. So we shall have 0.032, just like that. The diagram shows a quadrilateral with sides of equal length. And of course, this one is a rhombus, okay? The quadrilaterals which have all sides equal, we have a square and then a rhombus, okay? A rhombus. So that is that. And they're saying write down the mathematical name, rhombus. Simple as that. Mark the spelling. Part B, work out the value of A. In a quadrilateral, the sum of all angles is equal to 101. 360. Or when we look at parallel lines, okay, and I have this is B. In fact, let me write, let's say we have A here, and then we have B here, these interior angles here. Now, this one here is actually B, and this one here is actually A. These angles are corresponding, right? Now, when you look at these two here, they are angles on a straight line, so meaning they add up to 180. So meaning if you don't have these angles here, but you are seeing these interior angles here, then A plus B is equal to 180 degrees. You see that? So if we can have these ones equal to 180 degrees added together, then that means when you look at this quadrilateral here, I can also have this line here and this one here, they are parallel, and then these are interior angles. You see that? So I can have those two added, then we have A plus 2A, okay? Then we equate to 180 degrees. You see that? So this will be 3A, which is equal to 180 degrees, and then A will be equal to 180 divided by 3. So then A becomes 60. Okay, it should be 60. Alternatively, you can say, this angle here is actually the same as this one here. Then this angle here is also the same as this one here, 2A. So angles in a quadrilateral add up to 360. So I will say A, then plus 2A, plus A, plus 2A is equal to 360. 3 plus 3, you get 6. So 6A then is equal to 360. So meaning A shall be equal to 360, then divide by 6. Okay, this 6 here can go into 36 6 times. Then there is this 0. So you can get it also like that. So that is that. Then question 5, we are given sequences here. Part A, we have 1, 5, 10, 16, 23. And they are saying we find the next term in each sequence. Okay, so in here, we can see that they are adding 4. Then here, they are adding 5. Here, they are adding 6. Here, they are adding 7. That means here, we shall add what? 8. So that means our next term shall be 23, then plus 8. And this one will give us 31. Then the next one here, we can see that these numbers are powers of 2. Okay, they are powers of 2. So this one is 2 power 1, 4 is 2 power 2, 8 is 2 power 3, then 16 is 2 power 4, 2. This one here, you can see these powers 1, 2, 3, 4. So before you go to 1, don't you have 0? And any number to the power of 0 is always what? 1. So this one is 2 power 0. That means the next term here, the next term has to be 2 to the power of 5. And that is 2 times 2 times 2. So 16 times 2. Or in other words, you are actually getting this term here times 2. You get this. Times 2. You get 4. 4 times 2. You get that. 8 times 2. You get 16. Now 16 times 2. So this one then gives you 16 times 2, that is 32. Question 6. These are the lengths of time in minutes of some phone calls. 10, 22, 5, 7, 35, 8, and 75. Find the median. So to find the median here, we need to first arrange the numbers, okay? The numbers in maybe ascending order, and cancel them from the extremes. Cancel them from the extremes. The one remaining in the middle, so the one remaining in the middle is the median. As simple as that. So which one is the smallest? We see 5. So I can have 5. Then we have 8. There is 7. So we shall have 7, then 8. What else? I'm done with this, and this. Then we have 10. Then next, of course, which will be 22. Then 35. And then 75. Now in the exam, usually students do what I've done here. And they leave their paper ugly. So after cancelling those ones there, please rub this off, leave it clean. Okay, so I will cancel this and this one here, this one and this one here, this one and this one here, then we remain with this one here. So that means our median is going to be 10, and that is that. Then the range, for the range, we get the biggest value, okay, biggest or highest, whatever, minus the smallest value. And from here we see that the highest is what? 75, and the lowest is what? 5. And this one gives us what? 70. Then part B, we are saying the longest phone call is 75 minutes. Write 75 in hours. Now 75 minutes is the same as 60 minutes, okay, plus 15 minutes. Are we there? 60 minutes is the same as 1 hour, okay. Then 15 minutes, that is 15 divided by 60, because you know that 1 hour is equivalent to 1 hour is equivalent to 60 minutes. So 15 goes here once, then here 4 times. So that means you're going to have 1, then plus what? A quarter. So this one is the same as 0.25. So I can have my answer as 1.25 hours. Or I can say 1 and a quarter. You see that? 1 and a quarter hours. Question 7. 70 students study one of French, Spanish, and German. The ratio of the number of who study French to the number who study Spanish is 3 to 7. 15 students study French. Find the number of students who study German. So here we have those who study French, and then those who study what? Spanish. So I'll need to know the number of those who study Spanish first. So we have 3 here, then 2, 7. Okay. Now, these are 15 students who study French. So I can put a 15 here, and then here there is something. I'm going to ask myself, what did they do to this 3 to make it a 15? They multiply by 5, right? So times 5. Even here, they have to multiply this one by 5, and you get 31, 35. You get it? So that means for German, we shall have the total, which is 70, then minus, we get these two added together, 15 plus 35. So this one will be 70 minus 50. And this one will give us 20. As simple as that. Question 8. The diagram shows 2 faces of a net of a cuboid on a 1 centimeter squared grid. 1 centimeter squared means that here you have 1 centimeter, and then here 1 centimeter. So the area will be 1 centimeter times 1 centimeter. So it is 1 centimeter what? Squared. Then part A, they are saying, complete the statement. The dimensions of the cuboid are. Now, you can see this is how many squares do we see here? This is 1, 2, 3, 4, 5. Okay, then this is 3. So this will be the width, and then this one will be the height, because you can make it stand. When you fold it, you are going to get that. Okay, the 3, this will be the height. So it is 5 by 3 by 3. So that is 5 centimeters by 3 centimeters by 3 centimeters. And then part B, on the grid, complete the net of the cuboid. So first of all, I've said that you are having this cuboid here, and the dimensions are, we have 5 here, we have 3, and then we have 3 centimeters. So this one that is here, we replicate it, or we duplicate it, and then it comes this other side, okay? Because these are 2 faces. When I cut here, then here, and maybe here like this, here, you cut also here, and maybe this one goes this other side. This one will fall this way. Then if you also cut here, this side here, which is the same as this one, will fall this other side. So this is the one here. Now this one which falls this way is this one here. So these 2, this one here and this one here, they are the same, you see? So that's why I'm going to draw the same in this other side. So we are seeing these are 3, then 3. Okay, so I'll just go 3 boxes this way. Then after that, this same, I'll put it down here, you see? Then connect also this one to this, just like that. Then after that, when you see this one here, it is the height. I must have something here which is the same length actually. This one here has to be equal to this. So we should have something like this, such that when this one is folded, then this part here is going to join to this one, just as this one can join to this, okay? This same that I have here must come up here, okay? These 2 opposite faces, because when you look at what I'm having here, this face here, okay, is the same as the one behind here. You get it? So this is our base 5 by 3. Then I have this one which folds to our side, and then the one that folds the other side. You get it? And they are identical. So that means I will come here and I will, let me just copy this, then put it here, same length. Then of course the same also here, and then we shall put this one here. Of course, I've said we have to duplicate this one here. So I'll get this, duplicate it, and then put it here. But by the way, when you are doing the net, please use a what? Use a ruler. Don't use your free hands. You lose marks for nothing. Okay? So that is what we have there. And then, we have two faces that are identical. Now, this one here on top is the same as the one down here. So the one which is down is actually this one. So the face that is on top, I can take it along with this one. When I cut here, I cut here, cut here, cut here, cut here, cut here. Then this one which is on top will go with this one behind, and then they fold this way. Okay. So that means I'm going to duplicate just this one here. These are 3 units, then by 5. So very simple. I'll just actually take the 3 up here, then also here, and then take that on there. So usually this one here is the same as this one, like you jump 1 1, and then this one here is the same as this one, then this one here is the same as this, you see. So that is going to be our net. And in most cases, when they give you the grid, Like here they have left 1, then here we shall also have 1. You see there is 1 left here, and also up here there is 1 centimeter left up here. So it is always balancing. So that is that. And then part C, they are telling us to work out the volume of the cuboid. So volume of the cuboid is equal to length times width times height. This is a prism. So volume of a prism, we get the cross-sectional area times the what? The height. So when I cut this box like that as I go up, I will always be seeing this rectangular face here, okay, which is 5 by 3. Then times now this 3, that is the height as I go up. So we shall have, and this rectangular face, the area of a rectangle is length times width. That's why we have this, and then times the what? The height here. So this will be 5 times 3, which is 15. 15 times 3, then you get 45. And your answer becomes what? 45 cubic centimeters. Question 9. The diagram shows the net of a square-based pyramid. We can fold these ones back. So a pyramid, we are having, this one is a square. Then we have these slanting lengths like that. The perpendicular height of each triangle is 4 centimeters. Then the base has the side length 5 centimeters. Calculate the surface area of the pyramid. Now, total surface area of this pyramid is going to be, you get the areas of the faces, you add them. So this one is congruent to this one, and this one here, okay? So we shall have 4, or maybe first area of the square, then plus 4 times area of the triangle, because the triangles we have 4 and all are congruent. So area of the square is 5 times 5, okay? This one is also 5, 5, 5, like that. So we shall have 5 times 5, and then here we have 4, then times area of a triangle is a half base height. So a half, the base is 5, okay, then times the height, which is 4. Now this 2 here can go into the 4 2 times. Now 2 times 20, that is 40, not so? So here it is 25, then plus the 40, and this one gives us 65. As simple as that, 65 centimeters squared, because here you have a centimeter times a centimeter. This one is a centimeter times a centimeter. So you have centimeters squared everywhere, okay? Then part B, write down the number of edges of the square-based what? Pyramid. Edges. Okay, so let me actually shift this one here, and I put it here such that we can get the edges well. Now, an edge is a straight side. So this one here is 1, 2, 3, 4, then 5, 6, 7, 8. You see that? Not this one which I made dotted. It is just, I was referring to this middle part, this vertical height here, the vertex here, because it has to be aligning with the center that is here, okay? And that center is got by, if you get the diagonals, where the diagonals meet, okay? And those diagonals actually bisect each other. So those ones are 8 edges. Our answer is therefore 8. Question 10, part A, line A has equation y is equal to 3x plus 1. Line B has equation 3x minus 1. draw a ring around the description that is correct. Now, we know that the general equation of a straight line is y, which is equal to mx plus c. But when you look at these ones, the m is the same, which is the gradient. Okay. So, if lines have the same gradient, then that means they are parallel. Okay. So parallel lines have the same gradient. Okay. Now we come to this one here. They're saying line A intersects line B. They cannot intersect each other because they are parallel. Line A has a steeper gradient. No, they have the same gradient. The one that has a steeper gradient, that means it is bigger. Okay. A line can be like this. Another one can be like this. So this one has a steeper gradient. When you get the change in y, this one is a big change in y divided by a small change in x. But this one here has a smaller change in y and then a bigger change in x. So this one will give you a smaller value compared to this one here. You see that? Then what else? They're saying line A is perpendicular. No. Line A is parallel to line B. So this one is our answer here. Okay, that is that. Then next, of course, we don't need to look at this one, but they said line A and line B intersect y-axis at the same point. This one would be the same, but this one is plus 1 and this is minus what? 1. So that is that. Then part B, they are saying that on the grid, we draw the graph of y is equal to 2x minus 1. Now 2x minus 1, all we need to do is to draw a small table here, and then after drawing that small table, we can look at two coordinates. Maybe 2 coordinates are enough. Okay, and then after that, we draw a line through those coordinates. So if this is x, maybe I have y, I can have x being what? On the grid I can see x being 0. So you choose any x coordinates you want and you substitute, so long as the y coordinate you get is also there. Okay, and then here we can have, if x is 0, so put 0 here, y will be negative 1. Okay, then I can say let's put x is equal to 1. We'll put 2 times 1, that's a 2 minus 1, then you get a what? A 1. This one is also 1. So I come here and I put 0, negative 1. This is the point here. 0, negative 1. And then 1, 1. 1, 1. It is here. Okay. 1, 1 is there. And then we can now draw the line. So, another thing actually you can do like this. The gradient here is 2. Okay. So, and you know that gradient is change in y over change in x. So if it is 2, it is the same as 2 over 1. So this is change in y over change in what? In x. So change in x is 1 unit. Then change in y is what? 2 units. Do you see that? So 1 unit, 2 units. You go 1 unit, 2 units. 1 unit, 2 units. We move 2, then 1, 2, then 1. So all of those points are going to be on that line there. You see? So then we can draw a line all through. And this will be our straight line there. And whenever you draw that line, always label it. So I will say this is y, which is equal to 2x minus 1. Question 11. Joe asks 90 people whether they prefer pop, rock, classical, jazz, or folk music. The pie chart shows some of the results. And they're saying part A, work out the number of people who prefer pop. So pop, the angle we are seeing here is 120. So we have 120 degrees, but the total sum of angles is 360. In other words, angles at a point add up to 360. and 60. So I would say the portion of this one is 120 of the 301 and 60. Then times the number of people, they are 90. Now, of course, this one will die with this. 12 can go here once and then here 3 times. Okay. Now 3 can go here once and then here 30. You see that? So the whole answer is going to be 30. And that is that. Then part B, the sector angle for classical is 80. Okay. Draw this sector on the pie chart. So here, of course, we are going to use a protractor. Whenever they give you a diagram, they have always put not to scale. If at all the angles, you don't need to measure them. You get it? Not to scale. They are not measured in order to draw that diagram. But now here, we don't see that statement that not to scale. Usually they put it on the right side of the diagram. But now here, you're not seeing anything. So you have to draw or measure something. Now here they are telling us to draw this sector angle. So I'll get the protractor here. And when I get the protractor, I'll put it maybe here in the middle here. Make sure that your protractor, this one here, its center then matches with this one here. It coincides with that center. So I'll put it here. And then after that, I can rotate it. Okay. Maybe this other side like that. So that this line coincides with that. That of the protractor coincides with that. Okay, then we measure 80. So since I've coincided it with this one, then I'm going to use a scale which has 0 this way. Then I move what to 80. So 80, 0 is the outside one. Okay, this outside scale is the one that is moving like that. So 80 is here. So if 80 is there, then I'm going to get my ruler. We just put a small dot there. Okay. Then after that, you can remove your protractor. I can remove it. And then you get now your ruler. You draw. And then we make sure that you coincide it with this point which you drew. Okay. And when you do that, make sure that you put off this part here. And you can say this is 80 degrees, which is for what? Classical. So you also write that one there, classical. Then next, they're saying part C, 9 people prefer jazz and the rest prefer folk. Work out the size of the sector angle for jazz. 9 people prefer what? Jazz. So this will be jazz. The sector angle. Here it is going to be 9 people, but out of the total is what? 90 people, not so. So divide by 90, then times the total angle in the circle is 360 degrees. Now, this 9 here goes here 10 times. Then this 0 will cancel with that, and then we get what? 36. So our answer becomes 36. Then Roman 2, complete the pie chart. So we are going to draw this 36 here. Okay. So let me put degrees here. We are going to draw it here. I'll get my protractor. I can put it back here. Okay, like that. Then I can make it coincide with this one here, because now I have to use either this line or this one here, okay, to coincide with my protractor here. So what I'm going to do is to rotate this one here, maybe like that. Then, since I've made it coincide with this one here, I have then to measure from here going this way. Okay, this is my 0. So 36, you can see if I try to zoom, 35, but then 36 is here. I'll just put a dot. I can actually reduce this one here, and then I put off my protractor. You get your ruler, then you draw from the center there. Make sure that it passes through that dot which we drew here, and then we make it reach here. So that is that. So this is the one that is actually 36 degrees, and that is for jazz, I think so. For jazz. So I don't need to measure this one again, but what is remaining here is supposed to be for folk. So I'll have folk here, but which one is the angle? Okay, we shall say, let me write here for folk. So we shall have 360. We need the sector angle. 360, then minus 36, which is here. That is for jazz, not so? Then we have one for classical, which is what? 80. And then we have, there is this 120 and then 100. So we have 120, then we have 100. So this one will give us 360 minus, this is, first of all, this is 200. Okay, 200. Then this one will go to 300. So we have 336. Now, we need a 24 to add it to a 36 to make a 60. Also, this will be 10, take 1, 60. So from 36 to 60, it will require what? 24. So that means when I get 360, then minus 336, we shall get a 24. Okay, so meaning this angle here is 24 degrees. So that is that. Question 12. A music group has 30 members. 70 members play a flute and play a clarinet. Then 12 members play a flute. One member does not play a flute and does not play a clarinet. Use this information to complete the Venn diagram. Okay, now they are saying here, these 7 play a flute and clarinet. That is the intersection. Okay, then 12 members play a flute. So flute is the whole of this one here. That means I will get 12 minus 7. I will get a 5. So this is the 5 which you're going to get here. Okay, it will give us a 5. And then next, one member does not play anything. So I can put this one member here. Now we don't know what is here. That means to get what is here, I'll get the whole total, that is 30, then minus, I have 5 plus 7, then plus 1. Okay, this one here is 12, then 13, so you get 17. 30 minus 17, minus 13, we get 17 here. So that is that. And they are saying find the number of those who play clarinet. So those who play clarinet are going to be 7, then plus the 17, and then we get our answer as 20 what? 24. As simple as that. Okay, and that is what? 24. Then question 13 is saying by writing each number in the calculation correct to one significant figure, find an estimate for the value of this one here. Okay, so we have 62 here, 0.5. This one has three significant figures, and to one significant figure, we shall round this 2 here to this 6 here, and we shall add a 0. Okay, then this one here will go to the 6, but you cannot move from 60 and then you go to 6, right? So we have to put a 0 in the place of 2, so it goes to a 60. Then 9.7, these are two significant figures, so I'll round the 7 to this 9 here, plus 1. 9 plus 1, you get 10. Okay, now when I write this 10, they look like they are two figures, but it is one significant figure, because 0 is not a significant figure unless it is in between other what figures. Then how about 0.52? 0.52, 0 is not a significant figure because it is not in between other figures. If I had 5.02, here I would have three significant figures because 0 here is in between these other what figures. You see that? All right. So when we round off, we shall now round the 2 to this 5. Okay. A plus 0. You are not rounding this to this, because if you do so, you are rounding a significant figure to a non-significant figure. You are supposed to round this other figure to a significant figure. You see that? So this one will now be 0.15. So this simply implies that our calculation here, 62.5 out of 9.7 times 0.52, this one is approximately 60, then out of 10 times 0.5, this one will give us 60, then divide by 10 times 0.5, that is a 5, not so? And then 60 divided by 5 will give us a 12. As simple as that. So this has been it for this first part of the paper. Thank you so much for watching. May God bless you. If you find the content very helpful, kindly like, share, and even subscribe. See you in the next videos.